So, hi everyone. Today we would be looking at special paradigm structures of databases. We have certainly talked about storages and stuff, but definitely we haven't talked about how these special paradigm systems work. So, in this video, through an example, we are going to understand it. So, let's talk about the first one is blob storage. So, let's explain that through an example. So, we will consider a smart city project. We will consider a smart city project. So through this project, we are going to understand different kind of storage options. Like we have blob, then we have time series, then we have time series, then we have one more, that is graph, and then we have spatial database, then we have quad tree. So 3 to 4 we will look at. So let's start with blob 1. So I will take another color to explain it in a better way. So yes. So let's talk about blob. So just imagine this particular city has thousands of cameras. You have one camera here, one here, one here, one here, one here, one here, one here, something like that. It has thousands of cameras placed at interactions and key public areas, something like that. So yeah. So these cameras record video 24/7, and this massive amount of unstructured video data is stored in blob storage due to its scalability and capability to handle large amounts of unstructured data. So the reason we are using blob here is because it is a widely used kind of storage, in small and large scale of systems. They don't really, count as databases actually, partially because they have only allow user to store and retrieve data based on the name of the data. And usually people use this to store things like, you have some examples such as large binaries. Then you have, let's say, database snapshots. Then you have, images, let's say images, or any other static assets that a website might have. So a real life example to this can be, let's say in this city only there was a event done, and a video feed from a major public event or festival in the city gets stored in this blob storage. Now you must be asking, what are some kinds of blob storage? So we actually know, first one is AWS S3. AWS S3 is a very famous blob storage. Then you have Google Cloud Storage. These two services are very famous blob storage. So yeah. So this was it for the blob storage. Now let's talk about time series database. We will talk about time series database. Time series database. Cool. So now let's imagine for the same city we have an example. The city has a smart traffic light system. And the environmental sensors play a very crucial role in that. Now the traffic lights log the number of vehicles that are passing through. All the number of vehicles that are passing through every minute. And while environmental sensors, they store something like air quality. Then they store temperature. Then you have humidity at regular intervals. So real life example of this is over a year, traffic patterns at major intersections. Suppose this was one of the intersection. So are analyzed using this data to decide if a new flyover or road is required from here or not. So similarly, if a specific area constantly shows, deteriorating air quality, or the city might consider more green spaces or pollution, then we need to have some control measures there. So from this, what is exactly a time series database? So a TSDB is a special kind of database that is optimized for storing and analyzing time indexed data and data points that are specifically occurring at a given moment in time. So this was a very good example for that. So some names for some famous is influx DB. It is a very famous time series database. Then you have one name, Prometheus. They both are very famous time series database. You guys can go and just have a look on them on their website. They both are generally used for storing time series data. Cool. So we can move to our next one. So the next one is here. There you go. Then you have graph. Database. Cool. So it is a type of database that stores following the graph data model. So this is where I think if someone of you who has been part of any DSA course or problem solving course, you guys must have gone through how graph data structure works there. So you can connect a bit of things from there. So data entries in a graph database can have explicitly defined relationship. This particular node can have a relationship with this particular node, and this can have relationship with this, and this with this, and then this with this, something like that. Now graph database can take advantage of their underlying graph structure to perform complex queries. From here you can get the information of this also. So these are deeply connected data. So let's take another example for this, for the same city. This is the city. Now suppose the city is public transport system which includes buses, trams, or subways. Wants to recommend optimal routes to commuters. From this place you want to go to this place. You have one route from this, you have one route from this, you have one route from this, something like this. So now using a graph database, each stop or station is a node. So this is also a node. Here a node might be there, then you have a node here, you have a node here, one node here, something like that. Now using a graph database, we can actually point every stop or station as a node and the routes between them as edges. Now there is also one thing known as cipher. So this is a graph query language which is used within the graph database. If you want to actually do some complex queries in graph database, you need to know this language. This is graph query language, also known as GQL, graph query language, cipher. So this is an effort to call as SQL for graphs, something like that. So using cipher, we can actually retrieve the shortest path from here to here, and we can calculate the distance from point A to point B. Suppose this was point A to point B. We can calculate using graph database and cipher. Now a real life example for this. Suppose a commuter wants to travel from city library to a popular park, and the system recommends a route within minimum transfers and shortest travel time. So graph database is best for that. Similarly. So yes, this was it when it comes to graph database. So let's take another example for the next part, which is spatial database. We will study about spatial database. Cool. So how spatial database works? So suppose there is an internal inside the city only. There's an emergency response system that uses spatial database to track incidents and dispatch the help efficiently. Now you must be thinking, so what kind of database spatial is? So a type of database that is optimized for storing and querying spatial data like locations or on a map. So suppose this whole looks like there's some location here, then you have something here, something like that. So these are points and location accordingly on the map. So this is the spatial data. Now they rely on spatial indexes like quad trees to quickly perform spatial queries. It's totally fine if you are not able to get this, because spatial data and database and quad tree are a bit complex, but we will talk about them. So let's take a real life example. There's a fire in this residential building. Now the system quickly identifies the nearest fire station. Suppose this is it, and hydrates to dispatch the help immediately from here to here. So this was it for the spatial database. Now let's talk about the last one. Which is quad tree. Now, when it comes to quad tree, it's a bit complex. So take an example like this. A tree data structure, most commonly used to index this spatial data that we talked about. Now each node in a quad tree either has 0 children nodes or exactly 4. So it can either 0, let's say 1, 2, 3, 4. And inside this, you either have 4, more 4, or 0, nothing after this. And similarly for this. So typically a quad tree, contains some form of spatial data. For example, locations on a map with a capacity of some specified number n, and so these nodes aren't at capacity, they remain leaf nodes. Once they reach the capacity, they give more 4 children nodes here. So a quad tree, it lends itself well to us storing spatial data because it can, represent as a grid filled with rectangles and are recursively subdivided into 4 sub-rectangles. So where each quad tree node is represented by a rectangle. So yes, so this was it for the quad tree. Suppose you want to find something in the quad tree, so this would take an complexity of log 4 out of x by 4 because it's a quad tree and x is the query that where x is the total number of locations that are in there in the quad tree. So quad tree is basically used to represent the spatial data, and using spatial database you have a number of quad trees inside it. So you guys can go and have a look of how it looks on Google. So yeah, that was it from my side for this video. We can talk about a lot of other videos like in other videos about these kinds of database. Like you guys can go and have a look how these databases work. The example, like for graph, you have one very famous Neo4j. Go and have a look on their documentation, how they work. It's very interesting. So yes, in the next video, we are going to talk about replication and sharding in databases, why it is important part of system design and how you can do that. So thank you and have a nice day.